Okay, having a look at volume of pyramids and cones today. So I'm mostly going to focus on the cones. It's the same rule for both. We just want a third of the area of the base multiplied by the height. So whatever your base area is, if you've got a rectangle base or a square base, you can work out the area of that, times it by the height, and then multiply by a third or divide by 3. Or you can type that all in one go into your calculator. So most calculators are pretty good in that you can put all of that in one go. So you can use your fraction button to put the 1/3. Then you can put a bracket and put whatever your area is in there, and then close your bracket and then multiply by the height. Fairly straightforward. So I just want to look at two different ones here. So the first one is a cone. We've got a radius of 3 and a height of 5. So we're going to put our volume is equal to a third of our area times height, which in this case is a third of pi r squared times our height. So we've got a third, and we're going to do pi times our 3 squared times 5. So as I said, we can put that all in one go. So we can go 1/3, oops, 1/3, arrow across to make sure that we're then putting the next part in, times, and we want the pi. Then we're multiplying by 3 squared. So you can either make that 9 straight up, or you can use the squared on your calculator, or you can use the up arrow and then a 2 to do the power there. And then we are multiplying that by 5. On your calculator, if you've got this type, you will probably come up with 15 pi. Just press the little arrow here to take it to the decimal answer. So we get 47.12, and our unit is meters, so that will be meters cubed because we're working in volume. In the next one, I wanted to include this one because this is one that can be a little bit different and people may not recognize what to do straight away. So in this case, we haven't been given the vertical height of the shape. We've been given the slant height. And if you've done any surface area of cones, you will be familiar with what the slant height is, that distance along there. Now we want the actual height, so we can draw in a little dotted line here, and notice we have a little right angle triangle. So we can solve for that height here by using our Pythagoras theorem. So we've got c squared equals a squared plus b squared. Now in this case, our c squared is 10, our a is 6, or we could have put it for our b, doesn't really matter. So we get 100 is equal to 36 plus h squared. So I'm going to do 100 take 36, that's going to give me 64, and then I'll do the square root of that, and I will get a height of 8. Now I can go and do my question now that I've got my height and my radius. So I can do my volume is equal to a third of my area times height, which is a third of my pi r squared times height. So I've got a third of pi times my radius is 6 and my height is 8. And like I did before, I can put that all in one go. So I can use my fraction button, 1/3. I'm multiplying by pi times 6 squared times 8. And I get on my calculator 96 pi, so I will change that to 301.59. And that will be meters cubed.